Hi, welcome to my channel. In this session, we will be covering a lot of topics on very basic drug calculation dosages for new nursing students. And even if you're not a new nursing student, you may have been in the field for a while and you may not have been doing these drug dosage calculations. So this can also be a refresher course for you. Hope you enjoy. Thank you. On this slide is a brief introduction about myself and my nursing career. I would like to go right into the purpose of this session, okay? But if interested, feel free to take the time to read. In this slide, I'd like to begin with a tongue twister poem that I like to use for my class. I choose this poem because it requires you to be patient. It requires you to pay close attention to every detailed word that you are reading and pronouncing in order to get it right. It's the same principle when we are reading medication orders. Every single detail need to be paid attention to because the very slightest mistake can be fatal to the patient. So this is how it goes. Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, where is the peck of pickled pepper Peter Piper picked? I'm introducing you to the desired over half formula. You may be familiar with it already, which is fine. Some people are familiar with dimensional analysis. I look at dimensional analysis like a long train, and the desired over half for me is like the shorter version of that train, and we are all going to get to the same destination regardless of which one you use. Now, what is important, whether you use dimensional analysis or desired over half, what is very important is how you place your numbers and where you place them. Okay, if you do not place the key numbers in the right places, you are going to get the answer to your question wrong, regardless of which formula you use. Some people also use equation, ratio. It's all fine. Again, placement of your numbers or arrangement of your numbers is going to determine whether you actually get that answer right or wrong. So how is desired over half beneficial in drug dosage calculation? The desired is a key player, and often it is what you are being prescribed to give to the patient. It may sound something like, I want you to administer 20 milligrams of Tylenol to a patient. It may also sound something like, nurse must administer 20 milligrams of the medication to the patient. All that is what you desire to give. Okay, now what is the half indicator in this equation? The half is basically what you have available. So for example, if the doctor wants you to give 20 milligrams of Tylenol, what you have available is 50 milligrams. So the 50 milligram is what the pharmacy is dispensing to you. From the 50 milligram, you are going to take what you desired, which is the 20 milligram. Does it make sense? Okay, now we have medication bottles stored in our cabinets in our home. You can take a look. On the bottle, it should show you what you have available, okay? And what you desire to take is what you're going to, take. You're not going to take the entire bottle, right? Only what you desire to take is your desired. What is available on the bottle, the strength, the total strength is indicated to you on your medication bottle. That is what you have available. Now, quantity is another important indicator. Again, if you look at your medication bottle, it should tell you for the total amount of strength that you have available, which in this case I will use 50 milligram. That 50 milligram would also show you that it's equivalent to 1 tablet or it's equivalent to 5 milliliter, if it's a liquid medication. I'm just giving you an example. So whenever you see the available strength of the medication, also look at what is it equivalent to in terms of measurement. Okay, how many tablets do you have in relation to the 600 milligram of the Tylenol that you have at home? It may be equivalent to only one tablet. However, if you want to take two tablets, then you know that if your desired is two tablets, however, what you have available is 600 milligram for each tablet. All right. Now, the simple formula for that is you will have your desired dose given to you in the question. It's not something you're going to have to figure out. Rarely. Many a time you are given that desired dose in the question. And then you are going to divide that by what you have available. And then multiply the answer by the quantity that is equivalent to what you have available. Okay, we are going to see a couple of examples for you to see, for you. Now, another important formula you are going to need to remember is sometimes you are asked to convert your answer into a teaspoon or tablespoon. When that happens, always remember the cup is divided by the spoon. All right, you may have a cup of medicine that is maybe 20 ml. However, you are to convert that 20 ml into a teaspoon or a tablespoon. Again, knowing the conversion factors between ml and teaspoon or ml and tablespoon, just remember the cup is divided by the spoon. The cup may be 10 ml. It's okay, divided by the spoon. Now, another important formula you're going to need to remember is how to convert pounds to kilogram and the vice versa. Remember, the conversion factor for that is your magic number 2.2. Okay, now one way to help you remember when do you divide by 2.2 and when do you multiply by 2.2. So for example, I look at lbs, the pounds for big people. Is, many a time when adults go to the office and they get weighed, they tell us our weight in pounds. So pounds for adults, for big people. Kilogram, on the other hand, think of kilogram as a skinny K. A skinny K, often children's weight are also weighed in kilogram. They are recorded in kilogram because many of children's medications have to factor the weight of the child. And so think of kilogram for children, kilogram for skinny K. So if I am moving from an adult pound to skinny K, think of it as I'm going to lose weight to get skinny, like the letter K. In that case, we are going to divide whatever that number pound is given to us. We are going to divide it by 2.2 in order to convert that number to kilogram. Vice versa. If you have kilogram, think of it as, oh, I'm skinny K. However, if I have to convert my number to pounds, I'm going to gain adult weight, which is pounds. If I'm going to gain, I'm going to multiply. So therefore, I'm going to multiply by 2.2. I hope that kind of help you remember. When do I multiply and when do I divide if I have to convert between kilogram to pounds and pounds to kilogram. There is another magic number, 1000. Okay, so often we are going to be converting between grams to milligram to microgram. When that happens, many students often forget when to multiply by the magic number 1000 and when to divide. The quickest way I found to help students understand is if you look at gram is just one letter. If you look at milligram, it's represented by two letters. If you look at microgram, it's represented by three letters. So the way I look at it is, if I'm moving from gram to milligram, since I'm moving from one letter to two letters, I'm multiplying. Therefore, you remember to multiply by 1000. So if I have 1 gram and I'm asked to convert that 1 gram to milligram, I'm going to multiply by the magic number 1000 because I'm gaining two letters. Therefore, to gain is to multiply. Same way, if I'm to move from milligram to microgram. For example, again, I'm moving from 2 letters to 3 letters, and I'm gaining. So anytime I know I'm gaining extra letters, I'm going to multiply by that magic number 1000. Same way, if I am to move from milligram to gram, I may be given a question like convert 500 gram to milligram. If I'm, again, remember, gram 1 letter going to milligram 2 letters, I'm going to multiply that 500 by 1000. However, I could also be asked to convert 5000 milligram to gram. Remember, I'm moving from 2 letters to reduce to 1 letter. Reduction is for you to divide. So you divide by the magic number 1000 and you will get that answer. Same thing if you have to move from milligram to microgram or microgram to milligram. Always remember, am I gaining how many letters, or am I losing how many letters? Am I decreasing, or am I multiplying? Hopefully that trick would also help you to remember when to multiply by the magic number 1000 and when to divide. Let's begin to apply the divide over half formula and see how it plays in here. So I have Mrs. Piggy who sent the son Piglet with $10 to buy some more pigs to fill her pigsty. When Piglet went to the market, he found out that each pig cost $5. So how many piglet can he get out of the $10? So our desired order here is $10 worth of more pigs. What I have available, it says $5. The $5 is equivalent to the quantity of only one pig. And so what do? According to the formula, the desired dose is divided by what I have available, multiplied by my quantity of 1, and voila, I can only get 2 pigs out of the $10. Now, if we translate this to medication order, it can sound something like this. The doctor orders 10 milligram of medication for the pigs in the lab. The pharmacist said each medication box contains the strength of the medication, 5 milligram for each tablet. How many tablets can Piggy get then? Alright, apply the formula. Same thing. 10 divided by 5 multiplied by each tablet is 1. That would give you 2 tablets. Okay? This is another problem where desired over half is applicable. However, we add one little step to get it a bit complicated for you. As you must expect, the questions are not always going to be straightforward. So here, the desired dose, I want you to take your time to read. The order here says give 250 milligram of the medication. Okay, what do we have available? I bolded it for you. It's 50 milligram for each tablet. Okay, so can we identify our indicators to satisfy desired over half? So we have our desired dose 250. What we have is 50 milligram is equivalent to the quantity of 1 tablet. So if we work that out, we'll have 250 divided by 50, which is what? If you plug it on your calculator, I believe you'll get something like 5. Okay, but let's go back into the question. This is why I said that poem is so important to read and have that principle when you're reading your medication order. Let's go back to read the question. It says the doctor orders this medication for Mrs. Piggy and Piglet to be taken 3 days daily for 3 days because Pig played with the pigeons and they are sick with the pigeon flu. The pharmacist said each medication box contains 50 milligrams for each tablet. How many tablets of the medication can Piggy get for 3 days? So when we initially worked out the problem, we had 5. Now that 5 is only for 1 day. Since they want to know how many is he going to get for 3 days, we have to multiply that quantity by the number of days. In this case, the total now becomes 15 tablets. Okay, take your time and read it and try to work it out yourself. Just apply the formula, write the formula somewhere and apply all the time when you come across the question, and then go back into the question and find out what are you supposed to do with the answer. Okay. So this is an example of when we use we convert from pounds to kilogram and the vice versa. As you see the lady over here, she is doing some exercise to lose weight. So this is the concept over here. Now let's read the question. It says, when Piggy went to the market, he found that one pig was big enough to fill up the pigsty. He called Mrs. Piggy and told her that she found a pig that weighed 650 pounds. Mrs. Piggy couldn't understand weight in pounds. She grew up in a British colonized world where weight is calculated in kilogram only. So Piggy told him, well, to convert from large numbers to pounds, which is smaller numbers, we divide the pounds by 2.2, and then that's it, we get our answer. So let's put it to the test. Go ahead. If you should plug in 650 pounds divided by 2.2, what do you get? Whatever you get, that's your answer in kilogram. Now, if you should move that answer, remember that answer now is kilogram. If you should move that answer in kilogram and convert that back to pounds, what do you do? Again, you just multiply because you're going to gain the big pounds. So just multiply by 2.2 and voila. All right, our lady is still working out. So this is the new medication order. When you look at a question like this, it's important to understand what the question is trying to tell you first. Since if you are new to nursing language, okay, or the nursing mentality, this may be a bit confusing. So let me break it down. It says, give this is the dose over here. Give 0.07 milligram of the medication for each kilogram that the patient weighs per day. Per day is basically in each day. Okay, so it's important to understand that piece of the problem. So the doctor prescribes the medication 0.07 milligram for each kilogram that the patient weighs in a day. It is to be given twice a day in equal doses. The patient weighs 65 pounds. How many milligrams should be given? Notice that the dose is already in milligrams. Okay, notice that we are also giving the patient weight in pounds. So what do we need to convert here before we can solve the problem? We need to change 65 pounds to kilogram before we can solve the problem. There is no way you'll get this if you don't change the pounds to kilogram. And so in the next line I have done it. You can also do it on your calculator to make sure that we are doing, we're on the same page. So 0.5 milligram will be multiplied by the patient weight in kilogram. So in bracket, I have done 65 pounds divided by the magic number 2.2, and this you should get something like this on your calculator, 29.5454 da 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 da. Now that is the patient weight in kilogram. Okay, so multiply that by 0.07. and you should get something like 2.068, da 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 da, and that is the entire daily dose that patient will be getting in the whole 24 hours. Okay, so over here, if the question did not say that is given twice a day in equal doses, therefore what should you give per dose? If they do not say nothing like that, what we calculate here is the daily dose, and we leave it as that. However, the question is asking, they want to know how much is going to be given per dose. Per dose is just saying at each frequency, how much should the patient take? In this case, we were told clearly that is given in equal doses, 2 times a day. So the frequency here is 2 times a day. We go ahead and divide the daily dose by the frequency. which is 2, and that will bring us to the how much will be given in each dose. That's per dose as requested. All right. When you come across numbers like this, like I said, it's okay. Do not round anything until you get to the end of the question. At the end of the question, it should also tell you whether you should round or not to round. If you should round to the nearest whole number, for example, in this case, your answer is going to be 1. But if you are not told to round, just leave it alone. In many cases, we don't give this amount of medication, so you will be told to round, whether to round to the nearest whole number, the tenths place, the hundredths place. It will be made clear, it should be made clear in the question for you, and then you proceed as such. Okay, so you can take your time, rework the problem, and see, do you arrive at the same answer? Okay, our lady is still working out, so we still have some weight-based calculation to do. So this is also another example. In this case, the patient is given the weight of 120 pounds. However, our medication strength is different. So patient weighs 120 pounds. You have an order to give the medication 20 microgram for each kilogram of the patient's weight per day. Okay. How much of the medication would you give in microgram? And also, what is the calculation of the dose in milligram? So there are two parts to this. So the first thing we are going to do first and foremost is you have your weight in pounds, but you need a weight in kilograms to work with. So let's go ahead and do that calculation. You're moving from big pounds to skinny Katie. What do? We are going to reduce in size, therefore we are going to divide by the magic number 2.2. That's what I have done down here for you. Okay, the next thing is to now go ahead and plug in that number in place of where it says kilogram and multiplied by 20 mcg. Okay, which is what I did in the next line. 20 mcg times the weight in kilogram, and it gives you this long number, and that's your answer in the microgram, and that's the daily dose. Again, don't panic. I mean, I use big numbers, and you are likely to get big numbers just for the sake of the calculation, not practice. However, in real life, you will be told what to round to. Okay, and going back to the question, you are also asked to now calculate the same medication in milligram. How much is the patient going to take? Okay, at this point, since you have already converted pounds to kilogram, all you have to do is once again replace that number in place of kilogram, and then you have two options. You already have calculated the daily dose in mcg. You could just take that answer and convert to milligram. Remember, you're moving from 3 letters to 2 letters. What happens then? You're going to reduce in size. Therefore, you're going to divide by the number 1000. You could also do your conversion from 20 microgram to milligram, and then plug in the number, the weight in kilogram, and multiply those two numbers, and that will give you the daily dose. Either way, you should arrive at the same answer. Now, if you look at the answer in microgram and the answer in milligram, you see a big difference. If we should round the answer in milligram to the nearest whole number, you realize patient is only going to get 1 milligram of the medication. However, if you don't round, you have like over 1,000, microgram of the medication. Now the numbers are equivalent to the value of the units. Okay, I don't want to go into that. That's going to confuse you. That's why I made it so simple for you to know when to divide and when to multiply. But what is important is if you have to do the conversion and you don't do the conversion, this is where you're likely to end up giving a patient, you end up giving the wrong dose. That's why it's important to pay attention on when you need to convert. If you do not do the conversion right, you end up with the wrong dose of the medication to administer. I use these examples here to help you see the significance of you doing the conversions the correct way. Okay, and that will be it for this slide. In this slide, we have another conversion between grams, milligram, teaspoons, and tablespoons. So the question reads, give Piggy 0.5 gram of the pink medicine every 4 hours. The pharmacist sent down a bottle containing 100 milligrams for each 5 ml of the medicine. Now, how many teaspoons should the nurse tell Piggy to give? So first, let's identify what is desired here is 0.5 gram. What is available is 100 milligram. What is the quantity? The quantity said for each 100 milligram, we have 5 ml of the medication. So let's go ahead and solve for that. So if we remember our conversion, moving from gram to milligram, we are going to multiply by that magic number 1000. And so if you do that, you should end up with something like 500 milligram on your calculator. Divide that by your half if you plug in the formula for desired over half, and then you should also multiply by 5 ml. You should end up with a total medicine in ml of 25 ml. Now the question is not asking you about how much ml to give. All right, they're asking how many teaspoons would you give, and then how many tablespoons would you give if there are no teaspoons. So in that case, we need to know how many teaspoons then is equivalent to 5 ml, and how many tablespoons is equivalent to 25 ml. And so here, remember the equation, the formula says the cup divides the spoon. So go ahead, take your 25 ml, divide by, which one do you want to do first? If you're doing the teaspoon, that will be 5 ml. So 25 divided by 5 ml will give you 5 teaspoons. Okay, so out of the 25 ml, you can only get 5 teaspoons of the medication. And then it's asking, how about the tablespoon? Again, the cup divides the spoon. So take the 25 ml, divide by 15 ml, and voila, whatever answer you get, that is it. All right, always remember the cup divides the spoon. So this slide shows you the breakdown of the calculation we did in the previous slide. At the bottom, I included another example to show that sometimes the cup of medicine is not always going to be a larger number than the tablespoon or the teaspoon. And so I give an example. If your cup of medicine only holds 10 ml of the medication, however, they want to know how many tablespoons would you use to scoop out the entire medication. Again, the formula is the same. Just remember, the cup divides the tablespoon, or the cup divides the teaspoon. And so 10 divided by 15, you have a long decimal number, because 10 ml, if you look at 10 and 15, 15 is greater than 10, so there is no way that we are going to get a whole, the number out of the 10. All right, so we are going to end up with a decimal or a fraction of that cup of medicine, which is 0.66666. Okay, and then for teaspoon, since the teaspoon is less than the cup of medicine, we can get more out of it. So 10 divided by 5, we get 2 teaspoons. There are times when the question is so simple that, since students often are looking for what is complicated, they tend to look for more than is expected. the question can be as straightforward as that you have an order to give Tylenol 1200 milligram every 6 hours. How much would you give? Again, look, read and pay attention and take it as is. It says you have to give an order, um, Tylenol 1200 milligram every 6 hours. How much should you give? They only give you what is desired to be given and at what frequency. Now, here they are asking you how much would you give in a day. So every 6 hours you are given the medication in a day. We all know that in a day you have a total of 24 hours. Don't forget that. So if you are going to give this medication every 6 hours, how many 6 hours can you get in a day? Now that is the trick of this question. You have to know the number of frequency and then multiply it by the dose to get how many you will be given in the whole 24 hours, because this 1200 milligram is only at one time 6 hours. So the next 6 hours you are going to give another 1200 milligram. The next 6 hours you are going to give another 1200 milligram until we reach the whole 24 hours daily dose. So by the time you get to the end of the day, you are giving more than the 1200 milligram. Okay, so by calculation we have 4 of 6 hours in a whole 24 hours. So all you do here is take the desired dose, multiply it by the number of the total frequency, which in this case is 4. Okay, so 1200 multiplied by 4, you should get 4800. So 4800 milligram is what at the end of that 24 hours that's going to be that, the total dose. So your answer here is for 4800 milligram. There are also medications that are ordered, and there's a language that you may have to be familiar with. Now, when you go through your pharmacology or in fundamentals, you cover your medication administration week. I'm sure you will also come across what is called a scored tablet. So the scored tablets are often the pills that we see in with a line division right in the middle. It gives us the go ahead to be able to break it into two, or makes it easy for us to just put like an eating knife through just to break it into half. So that's your scored tablet. So sometimes the doctor would prescribe you to give this medication, but not in the full strength. Okay, so the order may sound something like this. The doctor prescribes a scored tablet which has 1200 microgram full strength, but the nurses has to administer only half of the medication. So how much of the medication in MCG would the nurse administer? So in a sense, they are telling you, although this scored tablet contains 1200 microgram, only give half. So if you have to give half, what do? We are going to break it into two. So with that same knowledge, let's go ahead and divide this medication, this desired dose, into two, and then there goes our answer, 600 microgram. That's half of the scored tablet, full strength. Okay. So again, the question can be very simple, but that's why it's important to pay attention when you are reading. What is the intent? What are they asking you to do? It's very important. All right, we almost getting to the end. To end with rounding rules. All right, there are so many rounding rules out there, and you may be asked to round, whether to the nearest whole number, the nearest tens, the nearest hundreds, the nearest thousands. So it all depends. So again, it's important, read your question from beginning to the very end. Don't skip. because sometimes we skip that rounding rule, and that is what will make us make the simple mistakes. Okay, so first of all, I'm going to cover only the very basic or the very common one that's often asked about, the nearest whole number, nearest tens, nearest hundreds. So it all begins with knowing your place values when it comes to the numbers. So for example, when you have a decimal number, an example would be like 0.66667. You have to know that any number right before that decimal point or to the left of that decimal point is your whole number. All right, so and everything else is to the right. That though everything else with a point before it is only a fraction, it's not a whole number. Okay, so I put some examples over here. Line 1, line 2, line 3 has a lot of numbers. Identify the whole numbers in these values. So for the first line, you see I underlined the 0. The 0 is in the whole number place, and that's it. So if you're asked to round this number to the nearest whole number, okay, so that's another formula on the next slide I'm going to show you. So this is just identifying the whole numbers in each number, and I have underlined them for you to see. Next, let's see if we can identify the numbers in the tens place. Okay, so I have repeated the same numbers. The left before the decimal point are the whole numbers, so we're not looking at them again. If we want to know what's the number in the tens place, we look at the number to the right of the decimal point. Now there are so many numbers to the right of the decimal point, but the very immediate one, the very first number after the decimal point is your tens place. So if you're given this number and you're asked to identify the numbers in the tens place, again I have underlined them for you to see. They are all the 6 6 and then a 0. Okay, lastly, we are going to identify the numbers in the hundreds place. Again, anything to the left before the decimal point is a whole number. Immediately to the right of that decimal point is your tens place, so we are not looking at that anymore. Now your next is the hundreds place, will be the second number after the number after the decimal point. All right, I have underlined it for you to see, and hopefully you also find a way to make it easier for you to understand. So the numbers in the hundreds place in this case is 6 6 and 3. In this very last slide, I am including when to include the rule of the magic number 5. So I repeated one of the decimal, some of the decimal numbers that we had in the previous slide. So as you can see, if you can go ahead and identify the different place values like we just covered, that would be great. But you may be, many a time you may have your answers probably looking like something like this, okay, with decimal and long numbers on your calculator. And so you can be asked to round your answers to, it could be the nearest tens, the nearest whole number, the nearest hundreds place. Okay, so we have to pay attention to these details. Go back to the Peter Piper poem. All right, train your mind to be able to pay attention to these very details. Otherwise, you miss them and you end up giving the wrong dose of the medication. So in this case, let's round this number to the nearest whole number. Now, first let's identify the place value. The place value for the whole number here in this whole numbers is 0, right? In all of these numbers, the place value for the whole number is 0. Next, in this rule is look to the very number right next to that whole number, which is 0.6. The rule of 5 says if the number immediately after the place value that you are looking for to round, if that immediate number is 5 or greater, it yields 1 point to the place value that you want to round to. In this case, our place value we want to round to is in the nearest whole number, the whole number value. The number immediately after that, after the decimal point, is 6. 6 is greater than 5, right? So it's going to yield 1 point to that 0, and so that number becomes 1. So rounding this number to the nearest whole number becomes 1, and we do not bring point nothing, anything. Everything just drops. Our answer is going to be 1. So in essence, you may end up with an answer like this for tablets, and you may be asked to round to the nearest whole number, and so your answer is going to be 1 tablet. Okay, looking at example B, you have 421.60. Round to the nearest tenths. Again, identify your place value for tenths, which is here is 6, and we are to round to the nearest tenths, right? Is 6. What is the number immediately after 6? Is 0. Is 0 5 or greater than 5 or less than 5? So if it's not 5 and it's not greater than 5, it's less than 5. If that's the case, the rule says it does not yield any point to the number of your place value that you are rounding to. So the number is left alone. Okay, so to round this number to the nearest tenth place, your 6 is in the nearest is the 10th place, so the answer becomes 421.6. Everything else is dropped and it stands alone. All right, hope you find this helpful. Thank you.